This lecture is on circuit symbols. It is imperative that you know all the symbols and functions of the various devices we talk about in this unit in order to be successful in the rest of the electricity unit. And kind of along those lines, it says, Edison failed 10,000 times before he made the electric light. Do not be discouraged if you fail a few times. So the goals for this presentation are that you be able to convert between a schematic, a physical circuit board, and actually words as well, and that you be able to draw and recognize the functions of all these particular symbols as well. So circuit design. These are the main symbols that you will see in the vast majority of circuits. However, there are more that we will go into, but these are present in almost all circuits that we talk about. They are single cell, battery, connecting wire, resistor, switch open, and switch closed. And we are going to go into them in more detail one at a time. So the first one is the voltage source. In this class, we're not going to distinguish between a single cell and a battery. They're going to represent the same thing. What a voltage source is, it provides the push that pushes the charge through the circuit. In this class, we're going to use batteries, we're going to use an outlet, but primarily we're going to use this right here. This right here is a variable voltage supply, and it allows you to change the voltage to whatever you want it to be. Remember, we talked about voltage already when we talked about electric potential energy, and we said voltage is really just energy per charge. So you should recognize voltage, and you should be able to relate it to other things that you've already learned about. Two, we have a connection. Now, the connecting wire is really what we're talking about here. It's used to connect the various elements of a circuit. It has to be made out of metal generally because metal conducts electricity. And if you think about it in terms of our water analogy that we're looking at, the connection is like the pipe that allows the water to move through what we're talking about. Same thing with electrons moving through a wire. The reason why it has to be a metal is metals have a loose electron structure that allows the electrons to move from one to another fairly easily. Next, we have the device. The device is better known as the resistor, and the resistor is anything that uses the energy of the circuit. So what it does is it actually impedes the flow of charge. It actually stops it, or it doesn't really stop it, it slows it down. Whenever it slows it down, it does so, it creates friction, which generally heats up and allows you to perform the function of the circuit. So if we use this kind of water analogy again, the light bulb is kind of like a turbine that the water, the current actually flows through, and it actually causes some sort of action to occur. Resistors tend to be heaters and light bulbs in this class, so something that will be heat up or something that will light up. Next we have the switch. The switch can be in the on position or it can be in the off position. Whenever the switch is open, there's a break in the circuit, so the circuit is not functioning or it's off. Whenever the switch is closed, the circuit is connected and therefore it is considered to be on. Switches are generally made up of something along these lines right here, where you have a piece of metal and you actually have a gap between the two. And so when you have this gap, electrons or charge can't flow through, and whenever you bring this metal switch down, it connects the circuit and allows it to go. So if we continue our water analogy, we say that the switch is like a faucet. It allows you to speed up, or it allows you to turn on the water, turn off the water, and in some cases you can actually have a different type of switch that will actually allow you to slow it down, so kind of like a dimmer switch. Next we have an ammeter. An ammeter is going to be very important because it's a device that actually measures the electrical current in the circuit. It has to be wired in series, and we'll talk about that a little bit later. And what it does is it actually measures how much charge is flowing through the wire at any given time. A key factor is it has very little resistance, and so these are things that you need to know, and we'll go into more detail a little bit later. One of the most important things about an ammeter, this is the symbol, this is what it looks like in the class, is you've got these three knobs right here. These three knobs will give you very different current readings depending on what it is. So for example, if it went to this 1 and it was on this knob right here, that would represent 1 amp. But if it was here, what that would represent is 100 milliamps or 0.1 amps. And here it would be 10 milliamps or 0.01 amps. So it's very, very important that you recognize which wire is connected to the knob in this particular case. The voltmeter. Voltmeter measures the potential difference or the voltage in a particular circuit. It has to be wired in parallel, and once again we'll talk a little bit more about that later. And what it does is it measures the push, or how much energy does each charge have. And it has very, very high resistance. This right here is the symbol, and this right here is what you'll see in the class. If you notice, there's just the two knobs. We can measure voltage from 0 to 5. It can't really measure 0.5 volts or anything like that like we can with the ammeter. Next, we have a fuse. A fuse looks like this. Is kind of this curly thing, and then you see a regular fuse, and you actually see a burned out fuse. And what it does is it actually provides a break in the circuit if there's too much current. Otherwise, it's just considered to be a connecting wire. So it basically has a resistance of 0 unless it's blown, and then it actually creates a gap in the circuit, almost like an open switch at that point. Drawing circuits. Now, we always draw circuits from, we start from the positive terminal, and we actually work our way back through to the negative end. Now, that's kind of an ancient relic of, they used to think it was positive charge that moves through the wire. Now we kind of know that it tends to be electrons more than anything. Even they don't really move. But the key thing is whenever you draw a circuit, you have to have a closed path. In other words, you have to have a way for something here to go all the way through the circuit and get back to the other end of the battery. Okay, things that you need for a circuit is, number one, you need a voltage source. Okay, you always have to have a voltage source so you don't have a circuit. Number two, you need some sort of connecting wire. You need a way to get from one end of the battery to the other. Generally, you need a resistor. Okay, now wires themselves have some resistance, but usually you need some sort of device in order for the circuit to make any sense. And fourth, you're going to have a lot of other things. You're going to have voltmeters, ammeters, fuses. There's other things that we'll talk about, but you need to make sure that there's other things that you can actually draw in the circuit as well. So by now, you should be able to convert between a schematic and a physical circuit board. You should be able to draw the function of all the circuit schematic symbols. So I should be able to say, draw a fuse, and you should be able to draw the symbol for a fuse. Or I can say, draw the device that that actually does something in the circuit, either heating up or lighting, and you should be able to draw that as well. And you should be able to distinguish between a closed and an open circuit as well.